When you open SolidWorks, you will face this window. This window is the initial interface of the software. To start designing from the top left, go to the File option and click on New. Or, as indicated here, use the Ctrl-N key shortcut. When you select the New option, this window will open and showing the three main modules of the SolidWorks software. The Part module, where we design parts or components. The Assembly module, where we assemble the designed components. And the Drawing module, where we create technical drawings from previously designed components and deliver them to the manufacturer. At the bottom left, there is the Advanced option, and when you select it, you will again see the Part, Assembly, and Drawing modules. If you have previously set specific settings for the Part module or designed a specific sheet for the Drawing module, for instance, a drawing sheet that includes the company logo, those settings and changes will be displayed in this section. Now, we go back to the previous section and select the Part module. Now we have entered the Part module, and we are ready to start designing. In this section, the 3D part is designed step by step. At the bottom left, by using the coordinate system, it shows us from which angle we are viewing the part. On the right side, we can assign a color to the part, apply a material, or use the library or toolbox of the SolidWorks software. The top section is the same. We can select a background, we can assign a color to the part, or take a section view of the part. And also, there are other commands here. On the left side, you can see the design tree. We can obtain a lot of information from this section. For example, we can understand which commands the designer used and in what order they were applied. We can even understand how proficient the designer was with SolidWorks by using the most optimized and minimal number of commands in Design Tree, something we emphasize a lot in these series. Designing your parts in a principled and optimized way. Designing a part has its own challenges, but editing that same part has even more challenges, something that happens a lot. If you haven't designed it in a principled and optimized way, you will face many challenges when trying to edit the part. This difference becomes more clear when your project is complex, with many parts involved. In the top section, we see various Commands tabs. If you've just installed the software, you may have fewer tabs. You can add any tab you want by right-clicking on any of the tabs and select the desired ones. You can activate the Weldments tab to bring its commands into the SolidWorks software. The tabs that are not included are specialized tabs designed for specific applications in the industry. For example, Weldments is related to welding and structures, or sheet metal, which is related to sheet metal work in the industry. When we open each tab, the commands related to that tab are displayed for us. So how do we start designing in the SolidWorks software? As I mentioned before, the foundation of the SolidWorks software is two-dimensional. This means that you must first be able to draw in 2D well, and then, by using the commands from other tabs, convert it into 3D part. So the first step is sketching. To draw a sketch, or in other words, to design, just like in reality, we need a plane to draw our sketch on. So the first thing we need to do is to select a plane. The SolidWorks software itself provides 3 planes, which are specified in the design tree. The front plane, where we view the object from the front. the top plane where we view the object from above, and the right plane where we view the object from the right side. If we need a plane other than these three, we start creating a plane in the software, which we will discuss in later sessions. So, the first thing I need to do for sketching is to select my plane, for instance's front plane. And then from the Sketch tab, I select the Sketch command. You can see that we entered the front plane and we are ready to sketch. Let me take a step back. Please attention. If I don't select a plane at first and click the Sketch command, the SolidWorks will ask me which plane I want to choose for sketching. Here I choose the front plane. So we must first select our plane and then enter the sketch and start designing. Another way to enter the sketch is to right-click on the plane I want, like the top plane, and then select the Sketch command. This way, the SolidWorks enters the top plane and we are ready to sketch. Another method for entering the sketch, which I personally use more often, is to left-click on the plane I want, like the front plane, and without moving the cursor, from the pop-up options that appear, select the Sketch command. This way, we enter the plane and we are ready to sketch. Let's pause here for a moment and review the changes that have been made right now. In the design tree, you can see that a note named Sketch 4 has been added, which is below this line. This means that we are in Sketch 4 and we are in the process of sketching, and Sketch 4 has not been saved in the design tree. So how can I save Sketch 4 in the design tree? I draw a line here. If I click the Exit option from the right side, it means that the changes I made will not be saved, and Sketch 4 will be completely removed from the design tree. If I select this option, the changes I made will be saved, and Sketch 4 will be saved in the design tree. As you can see, Sketch 4 is now placed above this line. So I can select a plane again, this time the right plane, and enter the sketch. To rotate the view, hold the middle mouse button and drag. And in this plane, I draw another sketch. This time I click the Exit option and you can see that the sketch is not saved in the design tree. We will talk more about rotate the view, select different planes and draw sketches on them in the next sessions when we are teaching 3D design. Right now, since we are focusing specifically on sketching, all sketches are drawn on the front plane. So we don't need to rotate the view right now, and don't worry about these tips for now. We'll cover them in detail later. Like the trick to making the view normal to the sketch plane will be explained in a later lesson. So if I make changes now and then click this option, the changes will be saved in the design tree, and Sketch 6 will be added to the design tree, as you can see now. This part is related to Sketch 6. If I select it, it will be highlighted, and this line is related to Sketch 4. I can easily right-click on either of them, or as before, left-click without moving the cursor and select the Edit Sketch command. I enter Sketch 4 again and I can make any changes I want here. For example, I move this line and place it here, and add another line in Sketch 4. Now I exit the sketch and sketch 4 is updated. Please attention, the exit button here is the exit button that completely exits you from the software, and the exit button here is the exit button that exits you from the part module and returns you to the initial SolidWorks window. Let's review our first exercise together. We'll go through it step by step and we'll solve it. To draw this shape, the first thing we need to do is determine where our origin or coordinate system is. In other words, to start designing where our starting point will be, which here it's clear that the origin is at the center of this line segment. Next, we'll try to sketch a shape similar to what we see here, in a very schematic way. Let's go ahead and do it. We don't need to worry about the origin's position right now, and I'll just draw the entire shape wherever I want on the plane. I open SolidWorks, press Ctrl-N, select the Part module. From the Feature Manager design tree, I select the front plane and enter the sketch mode. From the sketch commands, I select the Line tool. And as I said, I'll try to draw a shape similar to what we see here, just schematically. For example, something like this. I'll intentionally make the shape as rough as possible. So schematically, I'll draw something like this. In the next step, by using relations provided by the SolidWorks software, I'll try to make this shape look more like the one we see here. For example, if I want this line to be horizontal, I click on the line, and from the left panel in Add Relations section, I select the horizontal relation. From its shape, it's clear that this means the line will be positioned horizontally. It can be seen that a green horizontal relation displayed here, and the line is positioned horizontally. This means if I grab this point of the line and move it, the line can rotate at various angles. But once I add the horizontal relation, the line will remain perfectly horizontal in all cases, and it won't rotate. Similarly, I can select this line, and this time without moving the cursor, from the pop-up options, I choose the vertical relation. Again, I make this line perpendicular. I move the point, place it here. For making these two lines equal, I select the first line, hold Ctrl, select the second line, and without moving the cursor, from the pop-up options, I choose Equal. Or from the left panel in Add Relation, it can be seen that all applicable relations for these two lines are displayed by the SolidWorks software here. So I select Equal, and now you can see the green equal relation was added, and it shows that these two lines are equal in length. I repeat the same process for these two other lines, and I make them equal. If I want to remove a relation I've applied, I simply select it and press Delete on the keyboard. The horizontal relation was removed from the line. So first, we have created a schematic shape and then applied all the necessary relations. In the next step, based on the given dimensions in the drawing, we will define the dimensions for our sketch. The length of this line is set to 50 millimeters. To define 50 millimeters for this line, while I am in sketch mode, the sketch 1, From the Sketch tab, I select the Smart Dimension tool. Then, I select the desired line, and SolidWorks will show me its dimension. It doesn't matter what size I drew the line with when sketching. After sketching the shape and applying sketch relations, we select the Smart Dimension tool to define the dimensions. So, to set this line to 50 millimeters, I select the line, then left-click, and then type 50 here. Since I selected the MMGS unit system when setting up SolidWorks, the dimension of 50 is displayed as 50 millimeters. In the Part module, if you want to change the unit system, at the bottom right of the screen, you'll see the MMGS unit system. From here, you can select any unit system you want for dimensioning, such as IPS or inches, pounds, seconds, and other systems. We keep the MMGS system right now. Now I want to set the length of this line to 100 millimeters. So I go to the Sketch tab again and select the Smart Dimension tool. Then I select the line and type 100, or this time, instead of selecting the line segment, I could select this point and this point. I left-click. Here, I type 100. Notice that, because we applied the equal relation earlier, these two lines are now equal length. This line has a length of 50 millimeters too, and we don't need to define the dimension for this line again. To define a 45-degree angle, from the Sketch tab, I select the Smart Dimension tool again. And for this purpose, I select this line and this line. Since these lines are not parallel, we can define the angle between them. Here, I set the angle to 45 degrees. Once you select the Smart Dimension tool, you can apply all the dimensions. Let me first delete the dimensions I set earlier. To delete a dimension, I select the dimension. Make sure you don't click on the text because when you do, the SolidWorks will automatically prepare for Edit the dimension. Instead, select the dimension line. I click on the dimension and then press Delete on keyboard. So, once you select the Smart Dimension tool, you can apply all the dimensions. This line has a length of 50. We still in the Smart Dimension tool. This line has a length of 100. And the angle between these two lines is 45 degrees. To exit the Smart Dimension tool, I can simply press the Escape key on the keyboard. To define more dimensions, I need to select the Smart Dimension tool again. We defined a 45-degree angle between this line and the horizontal line. What if we don't have a horizontal line to define this 45-degree angle? In this case, we need to use the Centerline tool. I'll go to the Line tool and select the center line. A center line is used to assist in design but does not affect the design directly. I simply draw a horizontal line here, then apply a horizontal relation to it. Let me delete this dimension. And for defining angles, I use the center line. Another tip: When adding an angle dimension between two lines with the Smart Dimension tool, you can rotate the cursor to select different angles between them. So, I define a 45-degree angle here. Also, when you are sketching, the SolidWorks assists you in creating more accurate sketches. For example, when I move the cursor, the SolidWorks will highlight horizontal lines in yellow, and it will show me when a line is perfectly horizontal. This way, SolidWorks helps you to draw shapes more accurately. Also show vertical lines when they are perpendicular to another line. It also shows me vertical relation. If I move the cursor here, SolidWorks indicates that this point and this point are aligned. SolidWorks helps to draw shapes accurately. I select all these lines and press Delete. And again, I define a 45-degree angle for these two lines. Well, our sketch is now fully drawn, but the problem is that this sketch is currently blue, or as indicated here, it is underdefined. Underdefined means that you have drawn the sketch and may have fully dimensioned it, but you haven't fixed its position on the sketch plane, so you haven't defined your sketch. Either it's missing a dimension, or its position on the sketch plane is not defined. Now, we can see that if I select the line endpoints and drag the cursor, the shape's position on the sketch plane changes. Well, I just need to define the position of the sketch on the sketch plane to make it fully defined. For this, I can use the Smart Dimension tool to easily set the distance of this point from the origin, which requires a horizontal distance. Here, I choose it as 225, and I need a vertical distance. I choose this as 30. Now we can see that the sketch turns black and becomes fully defined. Why? Because we've added all the necessary dimensions and also defined the sketch's position on the sketch plane. I delete these dimensions, this time to convert the sketch from underdefined to fully defined. I can select this point, hold Ctrl and select this point. And from the Relations section, I choose the Coincident relation. This means that the 2 points we selected are coincident with each other. We can see the coincident relation here. To go one step back, I press Ctrl-Z to revert the sketch to its original position and remove the coincident relation. Now, the question is, how do we place the origin at this point here or at the center of this line segment? Well, what probably comes to your mind is that this dimension is 100, and we'll set a dimension of 50 for this length. So what should I do? First, I need to align this line horizontally with the origin point. So I select the line or one of its endpoints like this point, hold Ctrl and this point, and then choose the horizontal relation. Now, this line segment or these 2 points are horizontal with each other. This means if I drag the cursor up or down, the sketch doesn't move vertically but can shift horizontally. So I move the sketch here and place it. Now, at this stage, I select the Smart Dimension tool. Choose this line segment and my origin point, and set a dimension of 50. Now you can see the sketch is fully defined, with the origin placed at the center of the line segment. I press Ctrl-Z. Press Ctrl-Z again. Press Ctrl-Z again to revert the sketch to its previous position, and one more time press Ctrl-Z to remove the horizontal relation for these 2 points. This time, we're using a different approach. SolidWorks shows us the midpoints of line segments. When you hover over the line, the yellow point that appears highlights the midpoint of the line segment. Or, for this line segment, this yellow point is at the midpoint. I select this point, hold Ctrl, select this point as well, and then choose the coincident relation. Now, we can see that, much more easier, our origin is positioned here, and the sketch is fully defined. So we had an underdefined state where the sketch was blue, meaning the sketch was not yet fully constrained. Once we fully define the sketch, it turns black to indicate it is fully constrained. But there's another state called overdefined. What does that mean? That means you've set all required dimensions and the sketch is fully defined, but you've added one extra dimension beyond what's needed, and this is not correct from SolidWorks' perspective. How can we now make our sketch overdefined? I select the Smart Dimension tool. Now, for example, I set this dimension to 50, and I also select this line and this line as equal. Now, if I set a dimension for this line, for example, 51, SolidWorks quickly shows us that adding this dimension will make the sketch overdefined or unable to solve. Do you want to make this dimension-driven? Means just for display purposes? Or do you want to leave this dimension driving? So we select Leave this dimension driving to convert the sketch as overdefined. You can see that SolidWorks highlights overdefined elements in yellow. And here shows us that our sketch is overdefined. How can I take the sketch out of the overdefined state? Suppose we've drawn a very complex sketch, and it's not easy to figure out which dimension is causing your sketch to be overdefined. For this purpose, I double-click on Overdefined, and a window opens on the left side called Sketch Expert. Here, when I select the Diagnose option, it displays 3 solutions, each of which, if applied, will resolve the overdefined state of my sketch. The first solution tells me that the distance 12, which is shown here as this dimension, should be deleted. The next solution tells me to delete the distance 29, or this dimension. And the third solution tells me to delete the equal relation, which is shown here. After applying any of these solutions, such as the second solution, and selecting Accept, the sketch will transition from an overdefined state to a fully defined state. So, we have now learned how to resolve an overdefined sketch and achieve a fully defined state. But how can we take the sketch from the underdefined state to fully defined? Suppose we've drawn a more complex sketch, and one dimension is missing in the sketch. How can we figure out which dimension is missing? For this purpose, we simply grab the points of the line segments in the sketch and reposition them. Notice that we never grab the line segment itself. So, I select one of the points that is blue, like this point, and I reposition it. I'm moving the cursor in any direction, and I observe that this line segment does not rotate, only its length is changing. What does this mean? It means that a dimension might be missing here. Or I grab this point and move it. Again, it's observed that the length of this line segment is changing. so I can assign a dimension to it. Or I can even set the distance of this point from the line. So, by grabbing the endpoints of the line segments that are blue, notice that we only grab the points, and reposition them to figure out how to make the sketch as fully defined and which dimension we haven't assigned yet. Here, I select the Smart Dimension tool and set this dimension as 50 to make it fully defined. The final tip is that to set a dimension for this line or any line that is neither vertical nor horizontal, when you select them, SolidWorks automatically defines the dimension as the line's length. If you move the cursor upward, it defines the horizontal dimension of the line. And if you move the cursor to the right or left, it defines the vertical dimension of the line. We aim to create sketches in SolidWorks that are fully defined, indicated by their black color. But if the sketch is underdefined, as shown here, we can exit the sketch and save it in Feature Manager Design Tree without any issue. It's better that all sketches you create in SolidWorks are fully defined. In this exercise, we first sketched a shape. Next, we applied the necessary relations to the sketch. Then, using the Smart Dimension tool, we defined the dimensions. And finally, we achieved a fully defined sketch. As we mentioned, to create this sketch, we first need to define the position of the origin. Where to place the origin is something you'll learn through experience, but there are some tips to follow. First, it's best to place the origin on the sketch's symmetry line, such as this line. Second, it's best to place the origin where you want to start creating the sketch. For example, I wouldn't place the origin here if I want to start by drawing this circle. So in this sketch, I place the origin here. I start by drawing a circle with a diameter of 20, and then I begin roughly creating the sketch from this point. I open SolidWorks. I close this sketch project to start from the initial SolidWorks window. I press Ctrl-N and select the Part module. Now here, I select the front plane, and from the pop-up option, I choose the Sketch option to begin creating the sketch on the front plane. From the Sketch toolbar, I select the Circle tool. And then, to start drawing the circle, I place the sketch origin here. To draw the circle, as shown here, there are two different types. The first type is drawn using 2 points, one for the circle's center and another to define its diameter. The second type is drawn using 3 points. The first, second, and third points lie on the circle, and with these 3 points, the circle is fully defined. So I choose the first type to set the circle's center as the origin. My first selection is the origin itself, and the second selection sets the circle's diameter, defined by wherever I left-click. The size of the circle I draw now doesn't matter, so I can set any diameter, like this. I zoom out using the mouse scroll to make the circle smaller. The circle I draw might seem too large, but it doesn't matter as we'll define sketch dimensions in the next step. As I mentioned, from this point, I start creating the sketch roughly. I select the Line tool and, using SolidWorks Assistance, I try to start from a point below the origin as indicated by the SolidWorks. Then I roughly draw the sketch, and as mentioned, I utilize SolidWorks assistance. We can see that each line drawn with SolidWorks assistance has its relations highlighted and displayed. Well, to draw this semicircle, I use the Arc tool. So from the Sketch toolbar, I select the Arc tool. The Arc tool offers 3 different types, each with a specific method for creating arcs in the sketch. Here, since I want to use this point and this point, to draw it I use the third type. My first selection is this point. My second selection is this point. And the third selection defines the diameter of the semicircle. So, the first selection, the second selection, and third selection are done this way. Well, in the next step, we ensure the sketch we drew more closely resembles its intended design. First, I need to convert this arc into a semicircle. To achieve this, I need to align this point, the center point, and this point vertically. Then, the center of the semicircle must align with the center of the circle. So I select this point, hold Ctrl on keyboard, and select this point as well, and then apply the merge relation. Well, if the sketch becomes disorganized, we can adjust it by repositioning the line segment points. Now, since I'm intentionally drawing the sketch roughly and inaccurately to correct it later, this happens often, but it's primarily for educational purposes. When you gain more experience, you'll draw the sketch much more easily. So I organize the sketch like this. I apply another relation. These two lines need to be equal to each other. I hold Ctrl and apply the equal relation, again in the same way. I even need to make these 4 lines equal, so I select them and make them equal. These two are equal to each other. And I make this line and this line equal to each other. I move this point again. And since we've applied the equal relations, these two lines are equal in length to each other. Now I'll begin setting the dimensions for the sketch. I set the diameter of 20 and the diameter of 40. So I select the Smart Dimension tool, then select this circle to set a diameter of 20. I select this semicircle again. Here we see the radius is set to 32 for the semicircle, while we previously set a diameter of 40 for the circle. So I left-click here and type 20, meaning a radius of 20 or a diameter of 40. Again, a length of 10, a length of 20, and a length of 50. Length of 10. Length of 20. Length of 50. And a length of 10 millimeters for here. So our sketch is now fully defined, with all dimensions set and the origin placed at the circle's center. Please pause the video and try to complete this exercise on your own, ensuring the origin is at the sketch's geometric center. Well, since the origin is placed here, I first draw the sketch anywhere on the plane as desired. I enter the Part module. Select the front plane, enter the sketch, and start drawing the sketch using the Line tool. Then I make all these lines equal to each other. I hold Control, select these 4 lines and apply the equal relation. Alternatively, I can use the collinear relation to make these lines equal to each other. I press Ctrl plus Z to remove the equal relations. A collinear relation ensures that 2 or more selected lines lie on the same infinite line. For instances, I select this line, and I apply collinear relation. Here, we see that the dashed lines indicate these 2 lines are aligned. I apply the collinear relation to these 2 lines as well. This means these 2 lines are defined as equal to each other. So this is another way to make these 2 lines equal, but it's better to apply the equal relation here. I press Ctrl Z twice to remove the collinear relations. Here I make these 4 lines equal to each other. And then I select these 8 lines in total, hold Ctrl, and apply the equal relation. In the next step, I set dimensions of 60 and 45 for one line, applying them to all equal lines. I select the Smart Dimension tool, length of 45, and length of 60. Well, now if I select a segment point and drag it, the sketch's shape remains unchanged, but its position shifts on the plane. This is because the sketch is currently underdefined. You only need to define the sketch's position on the plane. To place the origin at the sketch's geometric center, I just need to calculate the horizontal and the vertical distances and set their dimensions from the origin. So I drag the sketch and place it here. And then I set the dimension for this point and this line to be half of this distance. We never perform calculations manually in SolidWorks. We only need to write what we want here. Like the length of 60, plus the length of 60, which is actually this length, plus this length, plus the length of 45. I put them in parentheses because they need to be summed first. And then I divide it by 2. SolidWorks performs the calculations, and the value 82.5 is set here. Similarly, for this point and this line, I enter the calculations. I write 60 plus 45 divided by 2, which again gives us the value 82.5 and the origin place at the sketch's geometric center. I press Ctrl Z twice to try a different approach. As we mentioned in the previous exercise, SolidWorks shows us the midpoint of line segments. I can simply select this point and the origin and align them vertically. I also select this point and the origin and align them horizontally. By doing this, the origin is automatically placed at the sketch's geometric center and the sketch becomes fully defined. In sketches with many relations, like this one, where they clutter the view, you can hide the relations if you don't want them displayed. From the Heads-Up Display toolbar, I select the Hide Show Items icon. It looks like an eye. Here, from the list that appears, you can toggle View Sketch Relations on or off. This means the relations exist in the sketch but are not currently displayed. To review them again, go to the Heads-Up Display toolbar from the Hide Show Items icon. Turn it back on. To draw a sketch, we first review all possible approaches and then choose the simplest one. For example, this sketch shows two squares, one rotated at an angle, with their inner entities removed. So, I use this approach to draw the sketch, as it's the simplest method. I enter the Part module, select the Front Plane, enter the sketch, and from the Sketch toolbar, I select the Corner Rectangle tool. In the Types section, I choose the second type, as it's important to place the origin at the rectangle's center. So I select the second type, choosing the origin as my first selection, and the rectangle's length as the second. To convert the rectangle into a square, you only need to make this line, and this line equal in length. From the Sketch toolbar, I select the Corner Rectangle tool again. This time, to draw a rectangle with a specific angle, I select either the third or fourth type of rectangle tool. Since it's important to place the origin at the rectangle center, I choose the fourth rectangle type. The first selection is the origin. The second is the rotation angle, displayed here. I select here. And the third is the rectangle's length. I convert the rectangle into a square again. Then, I specify the length and rotation angle of the square. To set its rotation, I make this line horizontal. Currently, our sketch is a square with no rotation, and only its size changes. Now, I just need to make this square, and this square equal in length. I select one side of this square, and one side of the other square. I hold Control, and then I apply the equal relation. We can now see that both sketches are the same size. In the next step, we only need to delete the inner entities of the sketch. For this purpose, from the Sketch toolbar, I select the Trim Entities command. The Trim Entities command provides multiple options for deleting inner sketch entities in various ways. And in this tutorial series, we often use the Power Trim option. The Power Trim option works by holding the left mouse button and dragging the cursor to create a trim path. This path indicates where you've moved, trimming the sketch entity at its nearest intersection. For example, if I drag the trim path from here, by holding the left mouse button and moving the cursor across, the entity between these two lines is deleted. So I hold the left mouse button and drag across the entities I want to delete. From the Heads-Up Display toolbar, I select the Hide Show Items icon and hide the sketch relations. I close the Trim Entities command. Our sketch is fully drawn but remains underdefined. As an exercise, add the necessary dimensions and relations yourself to fully define it and lock all degrees of freedom. Please pause the video and try to complete this exercise on your own. Well, this sketch can be created in several ways. Here we'll review 3 of those approaches together. The first approach, which you might have thought of too, is to use the line tool for these entities and the arc tool for these entities. I'll use this approach to create the sketch. The origin is placed here. I enter the Part module. From this section, I select the front plane, and I'm ready to create the sketch. From the Sketch toolbar, I select the Line tool and start creating the sketch from this point. So I start creating the sketch from the point vertically aligned with the origin. I zoom out using the mouse wheel to draw the sketch. I draw this line, then press Escape to exit the Line tool. From the Sketch toolbar, I select the Arc tool. And here, using the third type, I draw the semicircle, the first point, the second point, and the third point. I align these 3 points vertically. I select the Line tool again, and I draw these lines. I press Escape to exit the Line tool, select the Arc tool, and using the third type, I draw the semicircle. I align these 3 points vertically. I select the Line tool again. This time, to select the Line tool, I hold right-click and drag the cursor in any direction to open the SolidWorks mouse gesture. We'll cover the tips for customizing and setting up mouse gestures later. I drag the cursor to the left to select the Line tool. I draw the line. Again, I press Escape, select the Arc tool. Using the third type, I draw the quarter circle. To turn this arc into quarter circle, we just need to align this point and this point vertically in the same direction and align this point and this point horizontally or perpendicular to the previous direction. Well, this way we define the arc as a quarter circle. I select the Line tool again. I draw these lines. And using the third type of the Arc tool, I draw the semicircle as well. I align these 3 points vertically. And I make this point, the semicircle's center, and the origin coincident. Now I apply relations to the sketch. I need to align this line and this line in the same direction. So I select this line, hold Control, select the other line, and apply the collinear relation. I also make these 3 semicircles equal to each other, ensuring they have the same size and are linked. So changing one updates all 3. Now I set the sketch dimensions, a length of 30, a length of 70, and a length of 120. I select the Smart Dimension tool. Length of 30. Length of 70. And length of 120. A length of 30. I accidentally set this length to 30 here. A length of 30. I delete this dimension. Length of 30. And length of 30. I make these two segments equal to each other. A radius of 20 and a length of 60. So I select the Smart Dimension tool, select here, and set the radius of 20. And I set a length of 60 between these two lines. Well, the sketch has turned black and is now fully defined with all dimensions set. Okay, let's create the sketch using the second approach. I exit sketch mode to start drawing the sketch again. This time, based on the shape we see here, I'll try using tools in SolidWorks that match this part, specifically the slot tool. This shape is a slot, so I draw two slots, one here and another here, then connect them with lines. I enter the Part module, start sketch mode on the front plane, and then I select the Slot tool. Here, since the origin is placed here, I use the first type to draw the slot, to selecting the origin first. So, the first selection is the origin, the second selection defines the slot's length, and the third selection sets the slot's width. Again, using the first type of the Slot tool, I select the first point here, then the second point, and the third point. Then I press Escape. Using the Line tool, I draw a line here, and another line here. Then, using the Trim Entities command to remove the inner entities. However, using this approach, when I select the Trim Entities command and try to trim or remove a slot entity, SolidWorks shows an error. The error message here explains that removing the slot's entity will corrupt the slot's shape. We select OK here. Well, when the slot becomes corrupted, it causes the entire slot shape to break down. For example, with this slot, if you select this point and drag, the line remains horizontal, preserving the slot's shape. But here, if you drag this point, the shape no longer retains its slot form. So we need to reapply all necessary relations to restore the slot shape as intended, which makes the process more challenging. I have to make this line horizontal again. Select the arc and the line, then apply the tangent relation to make them tangent to each other. The relation is displayed here. I make this line horizontal. Trim this entity here. I select the arc and the line to apply the tangent relation and make it semicircle again. And so on. Add the other necessary relations to complete the sketch. This approach complicates the process, and we don't recommend creating the sketch this way. Okay, let's create the sketch using the third approach. SolidWorks allows you to create a continuous path of alternating lines and tangent arcs without switching tools, streamlining the sketch creation process. I select the Line tool and draw a line starting from this point. To draw a line and arc together in SolidWorks, I return the cursor to the endpoint and drag away to create a tangent arc. This way, without exiting the Line tool, it switches to the Arc tool, allowing me to draw the semicircle. It automatically switches back to the Line tool. I use the Line tool to draw this part. I return to the endpoint and drag to create a tangent arc. Like this. I draw the quarter circle using this method. And then, using the same method, I draw the semicircle. Well, now we only need to apply the necessary relations and set the dimensions to make the sketch fully defined. So we complete this exercise by drawing the sketch using 3 different approaches. The key point in creating this sketch is that this part uses the fillet tool. When 2 line segments, like this one and this one, intersect at a point, here at the origin, and form a sharp corner, replacing that corner with a rounded arc using the arc tool, such that the arc is tangent to both line segments, creates a fillet. In this case, we use the fillet tool to create these features. So, first, I draw 2 line segments intersecting at the origin, without adding the arc. Then, in the next step, I apply the fillet tool to create a rounded corner. I exit from the previous exercise, enter the Part module, and enter the sketch on the front plane. I select the Line tool and draw this line segment. Then I press Escape, enter the Line tool again, and draw this line segment as well. Here, this line segment should form a 45-degree angle with the horizontal. So, I draw a center line here as a reference. I can also do something else to create a center line. I can simply use the Line tool to draw a regular line. Then click on the line and use this command to convert it into a center line or a construction line. Alternatively, I press Ctrl+Z to revert it to a regular line. Select the line, and from the Property Manager on the left, under the Options section, enable the For Construction option to convert it into a center line. Then, using the Smart Dimension tool, I define the 45-degree angle. Now I set these 2 lines equal and make this line and this line perpendicular to each other. I set the length of 100. Well, in the next step, we should create this fillet with radius of 20. From the Sketch toolbar, I select the Fillet tool. To create the fillet at this point, first I enter 20 here as the fillet radius, and then select this point. Here are some key points about the Fillet tool in a 2D sketch. To apply a fillet, we must select a point, such as this one, where 2 line segments intersect. Note that we cannot create a fillet at this point, because no intersection point exists here for applying a fillet. To create a fillet here, I must first delete the lower entities, and then use the Fillet tool to create it here. So always at intersections where 2 line segments meet, we create the fillet. And always we select the point. Once again, I choose the Fillet tool, set it to 20, select this point, and then confirm the tool. In the next step, to continue creating the sketch, I use the Offset Entities command. In SolidWorks, offset refers to creating a duplicate of an existing entity, like a line, arc, or surface, at a specified distance from the original. What I want to happen right now is that all these lines I just drew are recreated at a distance of 10 millimeters, parallel to the original lines. From the Sketch toolbar, I select the Offset Entities command. As you can see, a blue line appears parallel to the drawn lines, indicating the offset in the sketch. I select the Offset Entities command, set the offset distance to 10 millimeters. And while the command is active, I select one of the lines to apply the offset. You can see that, although I selected only one line, the entire shape is offset by 10 millimeters. I reverse the offset direction to create it above this line. The Select Chain option allows the entire shape to be offset sequentially. If deactivated, only the selected line is offset. So I also activate the Select Chain option. To close the shape's end with a line, under the Offset Entities parameters, I activate the Cap Ends option. To close the shape, I can use either an arc or a line in the Cap Ends option. I select the Line option, so this way I draw the sketch with a 10 millimeter offset. In the next step, using the Arc tool with the origin as the center, I draw this arc with a radius of 80 millimeters. I select the Arc tool, choose the first type, set the origin as the first selection. Select this line segment as the second, and another line segment as the third. Then I enter the Smart Dimension tool or hold right-click and drag the cursor upward, and set this dimension as radius of 80. Again, like before, from the Sketch toolbar, I select Offset Entities command. I select this line, deactivate the Cap Ends option, and leave it as it is without reversing, with a distance of 10 millimeters. Finally, using the Trim Entities command, I delete the unnecessary entities. In this way, I define the sketch as fully defined. To draw this sketch, I first place the origin at this point, as it lies on the symmetry axis and is where I want to start sketching. Another point about drawing this sketch is that I use symmetry to create it. So I start drawing these lines, up to this point. I enter the sketch on the front plane. I select the Line tool. I convert this line into a construction line. I apply an equal relation to these two lines. I align these two lines, or I use the collinear relation. I think these two lines should also have equal lengths. Let's first set the dimensions. A 35-degree angle and a length of 35. I select this line, and type 35 here. Length of 35. A length of 50 and a length 100. I'll cancel this, and I press Ctrl+Z. Again, here a length of 35. I move these points so that the shape looks correct. Length of 50. Length of 100. And a length of 15. Our sketch is still not fully defined, so we select a blue point and move it, showing that the dimensions of these two segments need to be defined for the sketch to be fully defined. As I mentioned, I think these two lines should also have equal lengths, so I apply an equal relation to these two lines. Now we'll use the shape's symmetry and mirror the sketch along this axis line. From the Sketch toolbar, I select the Mirror command. And here, under Options, in the Entities to Mirror box, I select the entities that I want to mirror. In the Mirror About box, I select the axis line to use for mirroring. Now we see that the shape is mirrored about this axis line. And after applying the Mirror command, symmetric relations are added. This symmetric relation shows that this point is symmetric about this axis line. We can see here that all the points have the symmetric relation applied. I press Ctrl+Z to return to the previous step. This time, to mirror the sketch, I press Ctrl+A to select all entities. Since our axis line is defined as a center line, it's clear which entities are selected for Entities to Mirror and which entity is used for Mirror About. So I select all entities by pressing Ctrl+A. Then from the Sketch toolbar, choose the Mirror Entities command. It automatically detects entities and mirrors the sketch. I hide the sketch relations to display the shape more clearly. Let's go back to the reference image for this exercise. To draw these circles, since they follow a specific pattern as you can see, I'll use that pattern to create them. First, I create one circle with a radius of 5 millimeters or a diameter of 10 millimeters. Position 10 millimeters from the corner along both the X and Y axes. So, from the Sketch toolbar, I select the Circle tool. Here I draw a circle. Set its diameter to 10 millimeters. Set the distance from this point to this line to 10 millimeters. And also from this point to this line to 10 millimeters. From the Sketch toolbar, I select the Linear Sketch Pattern command to apply the specified pattern and draw the remaining circles. Here, two directions are defined. The first is along the x-axis, meaning this direction, and the second is along the y-axis. We can redefine them in a different direction using a line if needed. By default, it has already set the directions as x-axis and y-axis. Under the Entities to Pattern box, I select the circle. We can see that along direction 1, I adjust the pattern spacing to 20 millimeters. It is changed to 20 millimeters. How many times should the pattern repeat? The numbers are shown here. 5 instances in the x direction and 5 in the y direction. So I set the number of instances to 5. Here, the angle is displayed. To set a specific angle relative to the x-axis, if I define the angle, you can see how the pattern updates accordingly. I simply set the angle to 0. Then, relative to the y-axis, if an angle is needed, we can define it here. Why is this section inactive? Because the number of instances is set to 1. In the y direction, we don't want more than one instance, as it wouldn't make sense for this pattern. So I changed the number of instances to 5. I set the spacing between instances to 20 millimeters, with an angle of 90 degrees, that is, along the y-axis. And here, we selected the circle entity to apply the pattern. However, we don't want all the patterns to be created, like this one, or this one. To achieve this in the Property Manager under the Instances to Skip section, I select the instances I don't want to create. I select this instance, and this one, and any others I don't want created. Using the Linear Sketch Pattern command with the Define Patterns, we complete the sketch. Since I forgot to select this instance earlier and can no longer edit the command, I press Ctrl+Z to undo and redefine the parameters. I select the Linear Sketch Pattern command again. Set 5 instances with a spacing of 20. 5 instances. Spacing of 20. Select the circle entity, and then remove the unwanted instances. The sketch is now complete and formed as shown. To draw this egg shape, I start with a circle of 40 millimeters diameter here, and another of 30 millimeters diameter here. Then use the arc tool to create these curves, and trim the inner entities. So first I draw a circle with a 40 millimeter diameter here. I enter the sketch on the front plane, and using the circle tool, the first type, I draw a circle here. I draw another circle here. I align these two circles vertically. One circle with a 40 millimeter diameter and another with a 30 millimeter diameter. Now, I want the maximum distance, from this point to this point, to be 52 millimeters, or the outside to outside distance of these two circles, to be 52 millimeters. To set this dimension, you might suggest selecting the Smart Dimension tool, clicking here for one selection, and here for the other. But SolidWorks automatically provides the center-to-center distance of the circles, and this is not what we want. I just confirm it without changing the value. Now to change this dimension to the maximum distance, I select the dimension leaders. This displays all the settings related to this dimension in the left-hand panel. I can define the tolerance, whether it's included, its type, and the number of decimal places to display. Like this. We set this to the default document option right now. Here is the dimension name, the third dimension in Sketch 1. We can rename it for better design table readability and clarity later. This is the dimension's primary value when we draw the sketch. To set the dimension, we use the Smart Dimension tool to define it accurately. And I can add any text here. The DIM text typed here represents the dimension value displayed here. I can type anything here, and it will be displayed. I can also add any symbol here. So this tab covers the dimensions value options. Next, the Leaders tab in the Dimension settings defines the dimensions arrows. Here, I can adjust various settings in the Leaders tab for how the dimension arrows are displayed, as you see now, along with other settings related to their display style. In the Other tab, we have additional settings where we can change the font and make other adjustments. So, in the Leaders tab, since I want to change these two arrows, I go to Leaders tab, and at the bottom, under Arc Condition, I choose the Max and Max option. This shows the maximum distance, the outside-to-outside distance of this circle to this circle. Then I select OK. Now I select the dimension and set it to 52 millimeters. Exactly what I wanted has now been created. I press Ctrl-Z twice to review this again. Let me delete this dimension. If I selected the centers of the circles using the Smart Dimension tool, like this, and then go to the Dimensions settings in the Leaders tab, at the bottom, I don't see any arc condition option. Since I selected the circle centers or 2 points, there's no maximum distance option for these points, so I can't change it. To set the outside-to-outside distance, I must select both circles in the Smart Dimension tool, like this. Then I go to the Dimensions settings. In the Leaders tab, under the Arc Condition, I select Max to Max, and then I set it to 52 millimeters. I can also adjust the dimensions display in the Leaders tab. For example, I position it like this. Remove this line, and in Custom Text, set its position to center, so this dimension display this way. Next, we use the Arc tool to draw this curve. I select the Arc tool. Choose the third type. Select the first point here, then the second, and the third. Again, using the third type, I select the first point, the second, and the third. I select this curve and circle, then apply the tangent relation. If the arc is tangent on the wrong side of the circle, simply select the point and drag it this way. Again, I make this curve tangent to the circle. And this curve tangent to the other circle. Looking at the shape, it's a semicircle here, so these 3 points must be aligned horizontally. I select this point, the origin, and this point, then apply a horizontal relation. The sketch has become fully defined. Now from the Sketch tab, I select the Trim tool and remove the inner entities. So, this way, I've created this sketch as well. To create this sketch, I first draw a circle with a 300 millimeter diameter. Then use the Slot tool to create this shape. And finally, Use the Circular Sketch Pattern command to create these shapes based on this specific pattern. I enter the sketch on the front plane, and using the Circle tool, the first type, I draw a circle here with a 300 mm diameter. Next, I select the Slot tool. Under Slot Types, since the arc center of the slot aligns with the circle's center, I choose the fourth slot type. In this type, my first selection is the slot's arc center. So I select this point first, then this point, followed by this point, and the fourth selection defines the slot's size. Now the slot, or this point, needs to be vertically aligned with the origin. So what should I do? You might suggest selecting this point, and this point, then applying a vertical relation. But as we see, neither in the pop-up options nor in the left panel's Add Relations section is there a vertical relation. Why? Because this point selected here is part of the slot shape and not a point I can select to apply a relation to. So, what do? I use a construction line or center line, connecting this point to this point. Then I define this line as vertical. Now these 2 points are vertically aligned with each other. I set a radius of 130, a radius of 100. And 30 degrees. This means the circular sector of the slot spans 30 degrees. To define 30 degrees for the slot sector, I select the Smart Dimension tool. First pick this point, then this point to show their linear distance, and third pick the arc center to display the sector's angle. Let's try again. I press Escape to exit. Select the Smart Dimension tool. Pick this point, and this point. I press Escape once to go back, so it's like I only selected these 2 points. If I pick this point first, this point second, and the arc itself third, it shows the arc length. So with Smart Dimension there are 2 cases. First selection, second selection. Selecting the arc as the third pick shows the arc length, while selecting the arc center shows the angle. Here I select the center and type 30. In the next step, I create the remaining slot shapes using patterns. So I go to the Sketch toolbar, click the drop-down next to Linear Sketch Pattern, and select Circular Sketch Pattern command. Under Parameters, in this box, I specify the center point for the circular pattern, so we must select a point here. I select this point as the center for the circular pattern. Here we set the pattern to complete a full 360 degrees. Equal spacing means the patterns within the 360 degrees are evenly spaced. This angle is 90 degrees. This pattern spacing is 90 degrees, and these 2 are also 90 degrees. I type 6 for the number of patterns. In this box, I select the entity to be pattern, where SolidWorks automatically selects the slot. I clear it and select it again to show you. I confirm the command, and this way, I create the sketch. Please first pause the video and try creating this sketch with your own ideas. To draw this sketch, I start by creating two circles here with diameters of 30 millimeters and 50 millimeters. Then I'll create two more circles with diameters of 15 millimeters and 30 millimeters here. Then I'll apply the relations to them. And next, I'll use the line tool to connect the circles and then add fillets to these sections. So first I draw a circle with a diameter of 30 millimeters. I open a sketch on the front plane, select the circle tool, draw the first circle, and then draw another circle concentric with it. Let's say the circle I draw here is not concentric with the previous one. Let's place it here. To make the two circles concentric, I can make this point coincident or merge with the previous circle's center. Coincident and merge are often confused because they make points appear to overlap, but they serve distinct purposes. A coincident relation positions a point to lie on an entity, like a point on a line, where it can slide freely unless further constrained, like a point coincident with a line's endpoint or a circle's center. Merge, however, combines two distinct points into a single point, such as merging the centers of two circles or the endpoints of two lines into one. So here I apply the merge relation. I press Ctrl-Z. Another way to make the two circles concentric is to select both circles and apply the concentric relation. Again, I draw two more circles here. Make them concentric, and align their centers horizontally with the previous two circles. I'll apply dimensions, a diameter of 30, 50, 15, and 30 millimeters. Then I use the line tool to connect the circles. I select the line tool. If SolidWorks automatically applies a tangent relation while drawing this line, accept it, and then remove the tangent relation. In my case, it didn't happen. I align these 2 points vertically to meet at the same position. Similarly, I align these 2 points vertically. Now these 2 points move together like this. I set a dimension of 135 millimeters and a dimension of 16 millimeters. However, the 16 millimeter dimension will be defined after applying the fillet here, so for now, I set the 135 millimeter dimension. Then I use the Trim Entities command to remove the inner entities, allowing me to apply fillets at the intersections. I press Ctrl-Z. Notice that without trimming the inner entities, I can't add the fillet. Why is that? Because as I mentioned before, this point isn't recognized as an intersection, but once trimmed, I can apply the fillet here. So I must first trim this section, then apply the fillet. I set a fillet radius of 11.5 for all 4 corners. Type 11.5 here, and select the points in the Entities to Fillet box. I set these 2 points to have a distance of 16 millimeters, and the other two to have a distance of 25 millimeters. The sketch got messed up, but that's fine. We can grab a point and adjust it like this. "25 millimeters. So, this way, we complete the sketch. This sketch doesn't cover any new tips, so try to complete this exercise using your own ideas. To draw this shape, I start by drawing 3 circles. We can see their centers here. Then I'll reposition these 3 circles to form the shape I want. Next, I'll use the offset command to create these lines. And finally, I'll use the trim command to remove the extra sketch entities. So I open a sketch on the front plane and draw 3 circles here. I make these 3 circles equal in size. To apply the relations, I connect their centers with center lines to simplify adding relations. Now the triangle form just needs to be adjusted into a parallelogram, so I make the 3 center lines equal. I align this line horizontally and adjust the circle sizes to achieve the desired shape, like this. Since this is a SolidWorks practice sketch, it doesn't matter where the origin is located. Next, I offset the circles by 10 millimeters. I select all 3 circles. Here's an important note. We must first create the offset, then trim the extra entities. I press Ctrl-Z. If I trim the extra entities first, then try to offset, SolidWorks gives an error and won't offset. Even if I uncheck Select Chain to offset just this arc and try it for other arcs, making it very difficult to create the shape. So we must first create the offset, then trim the extra entities. The reason is that SolidWorks cannot properly offset the corners formed here. I press Ctrl-Z. I first create the offset for all three circles. Then I adjust the sizes and use the trim command to remove the extra entities. I hold Ctrl to select these three line segments and delete them. I return to the trim command and remove these sections as well. So, in this way, we complete the sketch. This sketch doesn't cover any new tips, so try to complete this exercise using your own ideas. To draw this sketch, I'll first create the large circle, then add two equal circles here and here, tangent to the larger one, and place two more equal circles at their centers. Using these tips, I go ahead and draw the sketch. I select the front plane and enter Sketch Mode. I draw a large circle, and then add two circles inside it. Then I draw two more circles inside those two circles. These two circles need to be concentric with the larger circles. And their sizes should also be equal. They also need to be aligned vertically. Now all four circles are vertically aligned. And the next step is to make this circle, and this circle equal and tangent to the larger circle. I make these two equal, and then make this circle tangent to the larger one, and also make this circle tangent to the larger circle. Now the sketch is formed. The next step is to make these two circles tangent to each other. I set the dimensions and then use the Trim command to remove the unneeded entities. And that's how I complete the sketch. To draw this sketch, I'll start by creating a circle with a diameter 25 millimeters. Then, I'll create another circle with the same center and a diameter of 45 millimeters. I'll place the origin here. Then I'll create a larger circle with a radius of 73 millimeters. And finally, I'll create this shape, and then this one, followed by a circular pattern from them. I enter the sketch on the front plane. Using the Circle tool, first type, I draw three concentric circles. Diameter of 25, 45, and a radius of 73 millimeters. And a radius of 73, which equals 73 times 2 in diameter. Then using the Line tool, I draw this shape, starting from this point, moving the cursor back to the same point to switch to the Arc tool, and then drawing this line again with the Line tool. I convert this arc into a semicircle, like this. I align this point vertically with the origin. Now I set the length to 12 millimeters, and the semicircle's center lies on the 77 millimeter diameter circle, meaning the distance from this point to the circle's center is 77 divided by 2. A length of 12 millimeters here. And I set the distance from this point to the origin as 77 divided by 2. There's also a circle here with a radius of 32 millimeters, its center located at a radius of 92 millimeters, meaning the distance from this circle's center to the origin is 92 millimeters. So I draw a circle here, aligned horizontally with the origin, with a radius of 32 millimeters, meaning a diameter of 32 times 2. And radius of 92. So the distance from this point to the origin is 92 millimeters. Then I use the circular pattern tool. Select this point as the pattern center. Choose equal spacing, 360 degrees, and create 6 instances for this entity and these entities. Finally, I use the trim tool to remove the extra entities from the sketch. This is how the sketch is completed. To start drawing this sketch, I'll place the origin at this point, as I want to begin with this circle, and most dimensions are referenced from this point. For example, dimensions such as 1.25, 1.25, and 3.4, among others. Another important note is that the dimensions in this sketch are in inches, so we need to change the unit system in SolidWorks. So first, I draw 2 circles with diameters of 0.75 inches and 1.5 inches. Then, I draw 2 circles at this point with a radius of 0.56 inches and a diameter of 0.5 inches. And I also draw 2 slots in this section. So I enter sketch mode on the front plane. I switch the unit system to IPS and draw 2 circles with diameters of 0.75 inches and 1.5 inches. When we switched the unit system, SolidWorks automatically exited the sketch. So the unit system is IPS, and we're sketching on the front plane. The diameters are 0.75 inches and 1.5 inches. There are also 2 circles here, positioned 3.4 inches horizontally and 1.25 inches vertically. With a diameter of 0.5 inches and a radius of 0.56 inches. That equals 0.56 times 2 in diameter. The distances are 3.4 inches and 1.25 inches. Now I draw 2 slots here. I use the first slot type. And draw another slot from the same points. With dimensions of 1.25 inches, 0.76 inches, and a radius of 0.75 inches. And this dimension is 0.76 inches. Here I slightly reduce this dimension. This point is located 5.5 inches horizontally and 2.75 inches vertically. The horizontal distance is 5.5 inches, and the vertical distance is 2.25 inches. Now to draw this section, as you can see, 2 arcs are used, one with a radius of 4.2 inches and another with a radius of 1 inch, with its center at a vertical distance of 1.25 inches. So using the arc tool, I start from this point, like this. Up to this point, the radius doesn't matter. Then using the arc tool again, I draw from this point to here, like this. A radius of 4.2 inches and a radius of 1 inch. This arc and this entity are tangent to each other. These 2 arcs are tangent to each other, and this arc is also tangent to the circle. As mentioned, the center of this arc is at a vertical distance of 1.25 inches. So I select these 2 points and set the distance to 1.25 inches. Now for the upper section of the sketch, there's another arc with part of it trimmed. So I draw an arc with a radius of 6 inches here. From the second circle I drew, I create a straight vertical line from its semicircle to intersect the arc. Then from the intersection point I create a fillet with a radius of 0.38 inches. This section can also be considered a fillet with a radius of 0.38 inches, but in this case, SolidWorks cannot create a fillet here, because the line we created here would completely disappear, and SolidWorks cannot generate a fillet at this exact point. So we have to use the arc tool to draw this section. I'll explain this section in more detail later. First, I draw an arc with a radius of 6 inches. Using the arc tool, third type. Connecting this entity to this entity. Like this. Then I make this arc tangent to this entity. And similarly, I make these two tangent here as well. A radius of 6 inches. As I mentioned from the semicircle section, I draw a vertical line intersecting the arc. SolidWorks automatically highlights the 4 circle points. From this point, I draw a vertical line to the arc, where you can see the vertical constraint applied. Then, using the fillet tool, I create a fillet with a radius of 0.38 inches. We'll apply the fillet at the end of the process. Now for this part, I draw a line from the semicircle. Make it intersect vertically with the curve. Let's first trim the extra entities here. I'm going to create a fillet here. I open the fillet tool, set the radius to 0.38 inches, and apply the fillet at this point. As you can see here, SolidWorks is displaying an error. That's because the line segment here is only about 0.19 inches long. So I can't create a fillet with a 0.38-inch radius here. This means that creating the fillet would make the entire line disappear, leaving no segment behind. So SolidWorks won't create the fillet here. What should I do? I undo back to before drawing the line. Using the Arc tool, I select the third type and connect this point to this one. Then I make these two tangent to each other. Make these two tangent as well. And set the radius to 0.38 inches. As you can see, these 2 points are no longer horizontally aligned, meaning the curve created here isn't a perfect semicircle. I trim the extra entities. And apply a fillet with a 0.38-inch radius at this point. The sketch is now fully defined. The dimensions in this exercise are in metric units. These numbers shown here are tolerances. Use the nominal value, such as 19 here or 28.5 there. Nothing else special. Try to complete this exercise on your own. As you might have guessed, I'll place the origin here. First, I'll draw 2 circles with diameters of 44 millimeters and 28.5 millimeters. Then I'll draw these circles and these slots at different distances. So I enter the sketch on the front plane. And I draw 2 circles with diameters of 28.5 millimeters and 44 millimeters. I draw 2 circles at distances of 19 millimeters and 48 millimeters, with diameters of 20 millimeters and 40 millimeters. The values are 48 millimeters and 19 millimeters. And two horizontal slots with a length of 22 millimeters and a radius of 22 millimeters. I use the first slot type. I draw another slot from the same points. These 2 points are aligned horizontally. Dimension of 22 millimeters. Radius of 22 millimeters. And a total length of 25 millimeters. This distance is 148 millimeters. So first I draw these 2 slots and then set this dimension. Since the slot's arc center is the origin of this circle, I use the fourth slot type, selecting the origin first, then this point, and the third point like this. Again from the same points. First, second, and third selections. This point is horizontally aligned with this one, so I apply a horizontal relation between them. Here, due to the same issues we discussed earlier with slot shapes, I can't align this point and the origin horizontally. So to align these 2 points horizontally, I use a center line. Draw this line, and then set it as horizontal. Angle of 40 degrees, dimension of 22 millimeters, and radius of 22 millimeters. I select this point, then this one, and the arc's center. Angle of 42 degrees. Radius of 22 millimeters. And dimension of 22 millimeters. This value is 40 degrees. Here we can see that these 2 points are not coincident. So I apply a coincident relation to make them align. I set the 148 millimeter dimension from this point to this point. And the dimension of 60 millimeters. To draw this section, I use the arc tool, apply a tangent relation, and set the radius to 44 millimeters. So I select the arc tool, third type, and connect from this entity. Since the segment center was selected, I press Escape. Again, I use the arc tool, third type, from here to here. Make it tangent. Apply another tangent relation and set the radius to 44 millimeters. Again, in the same way, I set the radius to 16 millimeters. For this section, I draw a straight line using the line tool and two arcs, one with a radius of 35 millimeters and one with a radius of 16 millimeters. I start from this point using the line tool, extending to the vertical point of this circle. I align these 2 points vertically. Then, using the arc tool, I draw 2 arcs. I select the third type. One like this, and another like this. I make these 2 entities tangent, and these 2 tangent as well. A radius of 35 millimeters and a radius of 16 millimeters. I make these 2 entities tangent as well. It seems one dimension is missing here. The point is that the center of this arc is coincident with the origin. So I locate this arc's center, move it slightly to reveal its center, select it to highlight the center, and make it coincident with the origin. Here it gives us an error due to the tangent relation. Or I can keep the tangent relation and remove the vertical one. The sketch is complete. It's not exactly clear where the arc ends here. If it's vertical, the arc ends here. If it's tangent, it extends to this point. So I draw this sketch like this. You should now be able to create this sketch on your own. So pause the video and try drawing it using your own ideas. The key point when drawing these consecutive curves is to fully define each one before moving to the next. First, draw a curve with a radius of 400 millimeters and an arc length of 100 millimeters, then one with a radius of 140 millimeters and an arc length of 90 millimeters, and continue this way until the end. As I mentioned, to create this sketch, I fully define each curve one by one before drawing the next. So I open a sketch on the front plane and start drawing using the arc tool from this point. I select the third type and draw the shape like this. I set the radius to 400 millimeters and the arc length to 100 millimeters. First selection, second selection, and the third is the arc itself. Next, another curve with a length of 90 millimeters and a radius of 140 millimeters. Set tangentially. I set the radius to 140 millimeters and the length to 90 millimeters. Then a radius of 90 millimeters with a 57-degree angle. Connected tangentially. I set the radius to 90 millimeters and the angle to 57 degrees. First selection, second selection, and third selection. A radius of 240 millimeters and an angle of 27 degrees. Then draw a line so that this point is horizontally aligned with the origin. So I make these two horizontal and these two tangent to each other. Here this point ended up too far away. With a dimension of 1,000 millimeters. So this section of the sketch is drawn like this. Since the sketch has become quite cluttered, I'll continue this section in another sketch. Note that this isn't best practice. For a closed profile, we should complete everything in one sketch. However, since this is just a teaching example and the sketch is getting cluttered, I'll continue in a new sketch. So I exit this sketch and start a new one on the front plane. Sketch 2. I draw the rest of the sketch here. For this section, I follow exactly the same method as before. Dimension 180 millimeters and radius 750 millimeters. I select the third type, like this. If you draw all the curves first and dimension them later, it will make your work much harder. Each dimension can distort the entire sketch. That's why, in this example, we fully define each curve before drawing the next one. I set the radius to 250 millimeters and make it tangential. Radius 125 millimeters. Set tangentially. I select the third type again, which roughly draws the arc from this point to this point, like this, and make it tangent with a radius of 125 millimeters. Next, another curve with a radius of 560 millimeters and a horizontal length of 165 millimeters, which roughly draws the arc from this point to this point. So a radius of 560 millimeters and a horizontal length of 160 millimeters with a tangent connection. And finally, a line that forms an 8-degree angle with the previous line and has a length of 935 millimeters. So from this point, using the line tool, I connect to this point, make it tangent, set 8 degrees, and a length of 935 millimeters. This way, the sketch becomes fully defined, drawn across two separate sketches. This exercise has already covered all the points, so try to complete it using your own ideas. To draw this sketch, I'll place the origin here and start sketching from this point. So I enter sketch mode on the front plane and begin drawing using the line tool. To fully define it, I set a 45-degree angle in lengths of 15, 2, and 3 millimeters. I also draw a center line with a total length of 60 millimeters. Next, using the arc tool, I draw this circular segment with a radius of 6 millimeters and an outside-to-outside distance of 14 millimeters. I select the third type. A radius of 6 millimeters and a distance of 14 millimeters. To set this distance, I select the arc and the center line. Confirm the dimension, then select the dimension leaders. In the left-hand panel, I go to the Leaders tab and set arc condition to max. Then, I adjust the dimension to 14 millimeters. a length of 10 millimeters, and a vertical line with a length of 1 millimeter. A horizontal dimension of 10 millimeters. Again, using the arc tool, I draw a quarter circle with a radius of 2 millimeters. Since this distance is 10 millimeters, and the quarter circle has a radius of 2 millimeters, the remaining distance automatically becomes 8 millimeters, and adding another dimension here would overdefine the sketch. I simply draw a quarter circle using the arc tool. These two are horizontal, and these two are vertical. A radius of 2 millimeters. The sketch is now fully defined, so there's no need to add the 8 millimeter dimension. Using the arc tool again, I draw an arc with a radius of 50 millimeters and a distance of 5 millimeters. Select the third type. "5 millimeters and a radius of 50 millimeters. Again, another circular segment with a radius of 2 millimeters and a distance of 6 millimeters. The distance is 6 millimeters, and the radius is 2 millimeters. And another circular segment with a radius of 9 millimeters. I connect this point to this one with a radius of 9 millimeters. To check which dimensions are still missing, I move the blue points in the sketch. As you can see, the center of this circle is moving. Upon checking the sketch, I notice the circle's center needs to be coincident with the center line. So I make this point coincident with this line. Moving the blue point again, I notice the circle's center is still not fixed. I can't find its dimension, so I set one manually to constrain it. I can also make these two vertical, which will fully define the sketch. Finally, I mirror the entire sketch. I press Ctrl-A and select the Mirror Entities command. So, this way, I've created this sketch as well. All the main points for this exercise have already been covered, so try drawing this sketch using your own ideas. To draw this sketch, just like the previous examples, I'll first draw a rough version of what I see. So I select the front plane. Enter Sketch Mode. Draw the center line using the Line tool. And then draw the rest of the sketch with the same tool. After finishing the sketch, Always check the automatic relations SolidWorks has applied. Remove any unnecessary ones, as they can sometimes conflict with your dimensions and cause errors. After completing the rough sketch, I apply the desired relations. I make all of these equal to each other. I also make these two equal. A key part of this exercise is figuring out the correct order for applying dimensions, something you'll get better at with practice. For example, after roughly sketching, if the overall length from this point to this point is 100 millimeters, but you apply a 125 millimeter dimension here, it will push that point outside the shape and distort the entire sketch. So the order of applying dimensions is crucial and improves with experience. If this issue occurs, start dimensioning from a different point. The dimensions here are 125 millimeters, 145 millimeters, 153 millimeters, and 190 millimeters. As you can see, all dimensions are defined relative to the origin, serving as the 0 point. How can we define dimensions relative to the origin? From the Smart Dimension drop-down, I select Horizontal Ordinate Dimension. So far, we've used Smart Dimension to define various dimensions. This option provides only horizontal dimensions, similar to Smart Dimension but restricted to the horizontal direction. This option provides only vertical dimensions, and ordinate dimensions allow us to define distances from a base point, which we can select as either horizontal or vertical. Since I want to set a horizontal dimension from the origin, I select this option. First, I select the origin as my base point, set as 0. Then, each point I select defines its horizontal distance from the origin. Now, the dimensions are clear. I enter 190 first, then 153, 145, and finally 125. Next, I set dimensions of 4 and 15. When I set the 15 millimeter dimension, as mentioned earlier, it slightly distorts this section of the sketch. Once all dimensions are set, the sketch will return to its correct form. Now, I set dimensions of 3, 2, and 1.5 millimeters. This dimension here is 7 millimeters. Next, I set fillets with radii of 20 and 30 millimeters. So I select the fillet command. First, I set a radius of 20 millimeters. Select this point and confirm the command. The command remains active. Now I set the radius to 30 millimeters and apply it to this point. Why doesn't the command close after clicking OK? By selecting the Keep Visible option, each time I click OK, the command remains active. allowing me to input new parameters and apply another fillet. If I disable Keep Visible, let me press Ctrl-Z. With Keep Visible disabled, the command closes each time I create a fillet, and click OK. When Keep Visible is enabled, I can apply multiple fillets without reopening the command. Finally, after fully defining the sketch, I press Ctrl-A and select the Mirror Entities command. This way, the sketch is completely drawn. You should be able to complete this exercise on your own to draw this section of the sketch, just like the Nike logo exercise we did earlier. Fully define each curve individually before drawing the next one. Some dimensions are provided in this view, and some are in the other view. This section might have some underdefined dimensions, which I'll show you how to fully define now. Sketch two center lines that are perpendicular to each other and apply the perpendicular relation. The midpoint of this center line is coincident with the other center line. Then, we apply a tangent relation here. We also add tangency relations here and here. And these two curves are made equal. So, go ahead and create this sketch using the method I just showed you. To draw this sketch, as I just explained, I start from this point and draw the curves. I enter a sketch on the front plane, and using the Arc tool, I draw a curve with a radius of 270 millimeters, an angle of 35 degrees, and a vertical dimension of 95 millimeters. A radius of 270 millimeters and an angle of 35 degrees. Next, a radius of 170 millimeters and an angle of 18 degrees. With a tangent relation. Then, a radius of 110 millimeters and an angle of 70 degrees. Which roughly draws from this point to this point, also with a tangent relation. (110 millimeters radius and a 70-degree angle. Next arc has a radius of 75 millimeters and an angle of 60 degrees. And then radius 238.24 millimeters, which goes roughly from this point to this point. With a tangent relation. And a radius of 238.24 millimeters. Next, an arc with a radius of 170 millimeters and a vertical dimension of 90 millimeters. I press Ctrl-Z here. First, I adjust the shape to get it closer to the desired tangency, like this, and then reapply the tangent relation. A vertical dimension of 90 millimeters and a radius of 170 millimeters. And finally, the last arc has a radius of 340 millimeters, which extends from this point to this point. All right, to keep the sketch clean, I'll draw the rest of the shape in a new sketch. So, I select the front plane again and start a new sketch. I draw an ellipse with dimensions 20 millimeters and 30 millimeters, horizontal distance of 280 millimeters, and a vertical distance of 170 millimeters. I select the ellipse tool and draw an ellipse here. A dimension of 20 millimeters and a dimension of 30 millimeters. And dimension of 280 millimeters and 170 millimeters. As you can see, the ellipse is still underdefined because it can rotate. To prevent rotation, we add a vertical relation between the center point and the two endpoints of the major axis. To sketch this section, I follow the same procedure I explained earlier. I select the centerline tool, draw one centerline here, then draw another one. I make the midpoint of this centerline coincident with this line. I make these two lines perpendicular. And I set the dimensions to 100 millimeters and 165 millimeters. I select this point and this line. dimensions of 125 millimeters and 265 millimeters. Using horizontal ordinate dimensions. With the 0 point here, I select this point and this point. Then, apply the dimensions 125 millimeters and 265 millimeters. And also dimensions of 55 millimeters and 110 millimeters. Next, I connect the points using the Arc tool. Then, I apply tangent relations to the arcs. And I make these two arcs equal. I exit this sketch and draw the remaining part of the shape in a new sketch. So, I enter a new sketch on the front plane and create this final shape. A horizontal dimension of 60 millimeters and a line length of 50 millimeters. An angle of 50 degrees and a distance of 155 millimeters. This is how we complete the sketch. To draw this sketch, we'll use a tool called Spline. As you can see, these sections are created with spline curves. But what's the difference between a spline and the arc tool we used earlier? The arc tool creates a circular arc with a constant radius. Mathematically, this means the rate of change of slope or curvature is constant, which is exactly why we get a perfect circular arc. However, in a spline, the rate of change of slope is not constant. It varies along the curve. As you can see, the slope changes much more sharply in this section. So even visually, it's easy to see when a spline is the right choice and when an arc is more appropriate. To draw this sketch, I'll first use arcs, just like before, up to this point. And then I'll explain how to use the spline tool for the remaining section. So first, using the arc tool, I draw a curve with a radius of 550 millimeters and an angle of 52 degrees. I enter a sketch on the front plane. I select the arc tool and choose the third type. Radius 550 millimeters and 52 degrees. First click, second click, third click. 52 degrees. And a horizontal distance of 550 millimeters. Again, using the arc tool, I draw one with a radius of 700 millimeters and an angle of 34.5 degrees. Select the third type. radius 700 millimeters, and 34.5 degrees. Now a radius of 1,230 millimeters and an angle of 15.65 degrees. I also draw the center line, like this. Now for this section, we'll use the Spline tool. From the Sketch tab, I select the Spline tool. I click a point here, another here, and the next one here. Then I dimension the positions of these points relative to the origin. So I set vertical ordinate dimensions of 345 millimeters and 510 millimeters. The origin is at 0. And these vertical distances are 345 millimeters and 510 millimeters. And here you see the horizontal distances. So I use horizontal ordinate dimension, set the 0 at the origin, and click these points. The dimensions are 45, 120, 218.5 millimeters, and 510 millimeters. Now, as you can see, the sketch is fully defined. But when you use the Spline tool, you'll notice handles at each control point. These handles represent how sharply the spline curves at each point. The angle of the spline handle shows the tangent direction of the curve at that point. The length of the spline handle represents the magnitude of the curvature. The longer the handle, the sharper the curve bends at that point. You can clearly see that here. To fully define the sketch, we also need to constrain these spline handles. As you can see, these two handles need to be vertical, and this one needs to be horizontal. I click this control point to display the handle arrow. Then, I select the handle and make it vertical. Same here. First, I roughly drag it to make it vertical. Then I apply the vertical relation. This one I first drag close to horizontal, then apply the horizontal relation. So, we've added 2 vertical relations and 1 horizontal relation to the spline handles. Next, we set the handle lengths. I read the dimension from here. Handle lengths of 320, 300, and 375 millimeters. Handle length of 320. The 300 millimeter handle length shown here is actually the combined length of the left and right handles at this control point. Each side has its own length, and together they total 300 millimeters. The drawing doesn't give separate values, but we can clearly see that both sides are equal, so each handle is 150 millimeters to make the total 300 millimeters. First, I make the handles equal, then drag them so each one is about 150 millimeters. Here, one handle is 330 millimeters and the other is 174 millimeters. I drag both down toward 150 millimeters. Now we're at 150 millimeters on one side. I just drag the other one to 150 millimeters too. Now, I set the total to 300 millimeters, and both handles snap to exactly 150 millimeters each. We get 150 millimeters and 149 millimeters. Close enough, they're almost identical. Then for this control point, I set the handle length to 375 millimeters. Now, the sketch is fully defined. Everything stays exactly where we want it. Next, for the remaining section, I draw another spline in a new sketch to keep everything nice and clean. I hide the relations. I mirror the entire shape and exit the sketch. Now, I start a new sketch on the front plane and draw the spline the same way. A vertical dimension of 53 millimeters. The sketch is now fully defined except for the spline handle lengths. We still need to set those. Angle of 15 degrees with a handle length of 130 millimeters. $15 and 130 millimeters for this handle. Again, using Smart Dimension, I click the control point to bring up the spline handle, then set 15 degrees and 130 millimeters. Here, the total handle length is 130 millimeters, so 65 millimeters on each side. Just like before, I adjust both handles towards 65 millimeters each. One's at 79 millimeters. I just pull it down towards 65 millimeters. Then, I set the total handle length to 130 millimeters, and I align it horizontally. And that completes the sketch. Actually, the reason I brought up this image is to show you another way to create spline. There's another spline tool called Style Spline. It gives us proper Bezier handles so we can shape the curve exactly the way we want. I placed this image here so we can import it into SolidWorks and put the two images side by side. This way we can first draw a regular spline that traces this hand-drawn curve from Photoshop, and then we'll do the same thing with the Style Spline tool, so you can clearly see the difference between the two. Later, you'll also learn how to import an image into SolidWorks and design directly over it. So if we can accurately reproduce this hand-drawn curve using a spline in SolidWorks, it proves that almost any free-form line from an image can be perfectly recreated in SolidWorks, and SolidWorks can handle anything. To give you a clearer understanding of how a Bezier curve actually works, I've prepared a short video that shows the mathematics behind it in action. We'll watch it together so you can see exactly how the control points and handles create the curve. Just a quick note before we play the video. You don't need to worry about the math at all. I'll give you a few simple explanations as we watch, so by the end you'll clearly understand how a Bezier curve is actually created and why the handles work the way they do. Here we go. I play it and talk you through the important parts. Look, at the beginning the video shows 2 points, P0 and P1. Between them there's a point called L0. That moves from P0 toward P1. Then it shows the equation for L0. It has a parameter called T. That goes from 0 to 1. As the parameter T changes from 0 to 1, point L0 moves smoothly from P0 to P1. So this equation now gives us the exact position of L0 at any value of T. That's the moving point we just saw. Next, it adds a third point called P2. Just like before, it creates another moving point, L1, that travels from P1 toward P2 as T goes from 0 to 1. It writes the same kind of equation for L1, again using the parameter T, so L1 moves from P1 to P2. Now it does the exact same thing one level higher. It creates a new point, Q0, that moves from L0 toward L1 as T goes from 0 to 1. So it writes the next equation following exactly the same pattern, again using the parameter T, but this time it combines L0T and L1T to give us Q0T. Here, as we follow the movement of Q0, you can see a curve starting to form. This curve is a Bezier curve, specifically a quadratic, degree 2, Bezier curve. So, a degree 1, or linear, Bezier curve is just a straight line. A degree 2, quadratic, Bezier curve uses 3 points, 2 endpoints and 1 control point, and produces a smooth curve exactly like the one we just saw. It substitutes L0T and L1T back in, does a bit of algebra, and out comes the classic quadratic Bezier equation. Next, it adds another point called P3. And just like before, it adds a new point L2 that moves from P2 to P3, and writes the same kind of equation for L2T. Then, it adds another point called Q1, and writes the same kind of equation for Q1T. It connects Q0 and Q1. It writes the equation for C0, the point that moves between them. Then, it substitutes Q0 and Q1 and follows C0. You can see C0 now traces a smooth curve. That gives us a third-degree, cubic, Bezier curve, shaped exactly like this. A cubic Bezier can change direction twice. it has up to 2 inflection points. So if we want 2 changes in curvature or 2 inflection points, we have to use at least a cubic, degree 3, Bezier curve. And a cubic Bezier always needs 4 control points. So you can never create 2 changes in curvature with a linear or quadratic Bezier. You need a cubic, or degree 3, curve for that. I hope that's all clear. Let's jump back into SolidWorks and see how these same concepts work with the spline tools. I enter a sketch on the front plane, and this time, I select Style Spline from the Spline drop-down. I leave the spline type set to Bezier. And just like the video we just watched, our spline works exactly the same way. Here we have a Bezier spline. 1 point, 2, 3, 4, 5, 6 points, degree 5. When I select it, you can see it says degree 5 right here. I can raise it to degree 6 or degree 7. The higher the degree, the more points I get. And that gives us much more freedom to shape the spline exactly how we want. But if I lower the degree from 5 to 4, watch, one of the curvatures disappears right away, as you can see now. So now it's degree 4. That means a maximum of 3 inflection points. 1, 2, 3. Drop it to degree 3 and we lose another inflection point. Drop it to degree 2. Now we're down to just 1 curve change. Okay, I'll delete this so we can bring the reference image into SolidWorks. To bring the image into the sketch, I first enter a sketch on the front plane. Then go to Tools, Sketch Tools, Sketch Picture. We'll cover Sketch Picture in detail later in the session where we design directly from photos. For now, I'm just importing the image using the method I showed you. Using these parameters, I can move, rotate, or resize the image. So with these settings, I click OK. Then I go back to Tools, Sketch Tools, Sketch Picture, and import the image again. This time, I move the second image to the left by the exact amount of its width, matching this dimension. So here, I type negative 837 millimeters. All right. Now we trace the lines on these images using both the Spline and Style Spline tools. So first, I trace the shape using the regular Spline tool. This way, I'm tracing the curve so it perfectly matches the line in the reference image I prepared earlier. Okay, now let's draw the same line again using the Style Spline tool. I see 3 distinct curves, this one, and this one. 3 inflection points mean we need a degree 4 Bezier. That requires 5 control points. So I select Style Spline. 1 point here, 2 here, 3, 4, and 5. And with these control points, I match the shape exactly. If you noticed, with the regular spline tool, we move the spline's points themselves. With Style Spline, the points stay fixed. We move the control points instead to shape the curve. So, using these control points, I shape the curve to match the reference exactly. Now, what's the difference between the two? When should we use the regular spline and when is Style Spline the better choice? If you right-click the spline and choose Show Curvature Combs, it instantly shows the curve's smoothness and radius of curvature. Let me increase the scale a bit so it's easier to see. Same thing for the Style Spline. Right-click and select Show Curvature Combs. As you can see, the Style Spline gives much smoother and softer curvature changes along the curve. But not here. Look at these sudden spikes in the regular spline. And that's exactly why the Style Spline is so much smoother. It's drawn using proper Bezier control points. But here it was drawn with standard spline tool. The curvature changes lose their smoothness and don't stay as clean and orderly as they do with Style Spline. I can increase the degree of the Bezier curve as much as I want. Let's turn off the curvature combs. If the Bezier degree drops below 4, we had the curvature like this. There, one inflection point is gone. Lower it again. Another inflection disappears. Keep going and it eventually becomes a straight line. So here we clearly see the difference between the two spline tools. Let's go back and draw this shape again using the regular spline tool. Of course, the more time you spend, the more accurately you can trace this shape. Like this. And then I draw the same shape using the Style Spline tool. Like this. It just takes a little practice to get comfortable with the tool. If you need more control in a specific area, simply increase the degree. You'll instantly get more handles and can shape the spline exactly the way you want. But keep this in mind. According to the video we watched, every 3 control points create 2 handle segments, and the curve between them is shaped. Okay, back to here. I increase the degree to get more control over the spline. All right, I draw it like this. Now I turn the curvature combs back on. I lower the scale a bit. Curvature combs are crucial for achieving high-quality surface finishes, ensuring smooth transitions for product design. The differences are clear again. So in this exercise, we learned how Bezier curves work, saw the real difference between regular spline and style spline, and successfully traced a hand-drawn line in SolidWorks using both tools.
In this exercise, we'll learn about the equation-driven curve tool and how to add text in SolidWorks. First, I draw this curve, a sine wave shape. So I enter a sketch on the front plane. I click the drop-down arrow next to the spline command and select Equation-Driven Curve. In this section, we can define the equation using two different types. The first type is explicit, where y is defined in terms of x, like the equation y equals sine of x. The second type is parametric, where two equations are written in terms of t. You can actually convert this equation to the first type. If you solve for t in terms of x and t in terms of y, and then equate the two t's, the first type of equation is derived. Since I want to define a sine wave here, in the y of x field, I write sine of x. In the parameters section, I have x1 start from 0, up to 2 pi to create a full sine wave. I set it to go from 0 to 2 times 3.14. Now, sine x is actually drawn for us here, but it's very small. Because based on the MMGS unit system defined here, the entire amplitude of the sine, meaning from this point to this point, is 1 millimeter, and the total length, or 1 period, is 2 times 3.14, which is also in millimeters. To make this larger, I need to modify the equations. The first thing I do to make the amplitude 100 millimeters is multiply it by 100, essentially scaling the amplitude by 100. I type 100 here, and now the amplitude becomes 100 millimeters. To increase the period, or wavelength as well, I divide x by 100. This way, I've extended the period. However, in the parameters, I told it to draw up to 2 times 3.14, so it only drew this small portion of the sine. To draw the full wave, I also need to multiply the x2 value by 100. And there we go. The sine shape I wanted is now drawn. Next, in the options section, I check for construction to turn this line into a center line. Now, I want to place the text along this line. I create the text using the text command here. To use the text command effectively, you usually need a reference line. That's the path the text will follow. So first I identify the line, and then I select the text command. In the Curves selection box, I select this line to place the text along, then type my desired text here. The line I want the text to follow is this sine wave. I select the text command, choose the sine wave in the Curves box, and type the text in the text field. The text is created, but it's quite small. To make it larger, I uncheck Use Document Font so I can adjust the font settings. In the Font section, based on settings I used before, I set the units to 60 millimeters. The text is now generated. If we increase the size even more, it will be clearly visible. So that's how we create text within the SolidWorks. There are also several commands here for moving the entities we've created, as well as copying, rotating, or scaling them. We will quickly review these in this exercise as well. If I select Move Entities, I want to move all the text here. It asks me to select the entities to move, so I select Everything. If I check Keep Relations, the existing constraints and relations between the entities won't be broken. In this section, with From To selected, I specify a start point, like this point here. The shape moves relative to that point, so I can place it wherever I want. And if I select the X/Y option in the Move Entities command, it moves the object using delta X and delta Y values. In the same way, the other commands, Rotate Entities, Copy Entities, Scale, and Stretch, work just like Move command. Feel free to explore them on your own. So far, for every sketch we've drawn, we've emphasized that you must first select a plane and then draw the sketch on that plane. However, selecting a plane is essential for the standard sketching method. If we want to create a 3D sketch, we no longer need to define a plane. Instead, we can draw directly in 3D space. Let's take a look at how to create a 3D sketch together. In the Sketch tab, I click the drop-down arrow next to Sketch and select 3D Sketch. Now, SolidWorks doesn't ask me which plane I want to draw on the sketch. I'll select the Line command. Notice that under the pencil icon cursor, it says X, Y. This means that based on the coordinate system here, we are currently drawing on the XY plane. If I press the Tab key on the keyboard, XY changes to YZ, meaning we are now drawing on the YZ plane. I press Tab key again. It changes to ZX, and I can draw on the ZX plane. I hold the middle mouse button and drag to rotate the 3D sketch and view it from different angles. We can see how we've drawn a 3D sketch in 3D space. Okay, now let's apply this concept and draw the shape. I enter a 3D sketch, and I start by drawing a square on the ZX plane. The exact dimensions don't matter in this exercise. I'm just showing how to build the shape in 3D Sketch. You can add dimensions later if you want. I select the Rectangle tool and choose the second type. I press Tab once, then Tab again to switch to the ZX plane. First click at the origin, then the second click. I make these two equal. In the same way, I draw these 4 lines using the Line tool again. So I select the Line tool. I switch to the YX plane by pressing the Tab key and draw the line. Line tool again in the XY plane. And then I make these 4 lines equal to each other. If we toggle Show Relations on, we can see a relation called along Y here. SolidWorks automatically applied it to the lines while I was drawing. Essentially, this line is aligned along the Y-axis. In 3D sketching, SolidWorks adds these specific relations: along Y, along X, and along Z. Using the rectangle tool again, this time I select the first type on the ZX plane. So I press the Tab key and connect the lines like this. Just like before, I create the lines using the Line tool on the YX plane. I apply an equal relation to these 4 lines and this reference line so that all 8 lines become equal. Using the Line tool again on the ZX plane, so I hit Tab to switch to the ZX plane. I connect these lines. To draw this section, I'll use a different approach. First, I'll define a plane here, and then draw the 3D sketch on that plane. We'll cover plane creation in detail in future sessions. For now, I'll just give a quick explanation here so you get familiar with defining a plane inside a 3D sketch and drawing on it. So, while I'm still in the 3D sketch, I select the Plane command. Here, it asks for 3 different references. To define a plane in 3D space, we need a maximum of 3 references, meaning we can define it with 1 reference, 2 references, or up to 3. Since I want the first reference to be parallel to the top plane, I select the top plane here. It automatically sets the relation to parallel and just asks for the distance. I set the distance to 300 millimeters as an example, and then click OK. As I mentioned, we'll cover constraints and plane creation in detail in later sessions. So the plane is created, and from now on, all sketching will be on this plane. I select the rectangle tool again, and using the first type, I draw a square here. I convert this rectangle into a square by applying the equal relation. Actually, let me draw this shape using the second type of rectangle tool. So, rectangle tool, second type, like this. Well then, in the next step, I turn this into a square. To align this point, normal to the origin, I use the normal relation, like this. Because here, a vertical relation doesn't really apply in the same way. Vertical is defined relative to this specific plane. Currently, these lines are horizontal, and these are vertical on this plane. So these 2 points cannot simply take a vertical relation. I also make this line and this line equal to each other. Now, to exit this plane, I'll double-click anywhere in the graphics area to leave the plane and return to the main 3D sketch environment. Using the Line tool on the XY plane, I connect the lines. For this section, I define a plane in the same way, passing through this line and this line. So again, my first reference is this line. My second reference is this line, and the plane is defined. I click OK. Then, I can rotate the view normal to the plane by holding the middle mouse button. Using the Arc tool, third type, I create a semicircle like this. Then, I double-click anywhere in the graphics area to exit the plane. I receive another plane. For the first reference, I select this line. For the second reference, I select this line, then click OK. And then on this new plane, I create the shape using the third type of the arc tool. Now, to edit the sketch on this plane, I just double-click the plane. That puts me right into edit mode. To exit, I double-click anywhere in the graphics area to leave the plane. So, that is how we create 3D sketches.